Hello, I'm Dr. Malescu, and today's lesson is a little micro lesson on osmosis. So a lot of people have trouble with understanding this, but it really is the movement of water. If you understand that it's movement of water from a higher concentration to a lower concentration down the concentration gradient. Now, yeah, that's the definition, and I don't want you to just memorize it. I want you to understand why the movement occurs. So the movement occurs because water molecules, they go from an area of where there's a lot of each other to an area where there's less of that particular molecule. And in this case, we're tracking water. So water doesn't like to be amongst other water molecules crowded. So it's going to go to a less crowded area. That's the best analogy that I can give to understand the movement of water osmosis. So the movement of water is from a higher concentration of water itself to an area of less concentrated water. So in the area of less concentrated water, it must mean that there's something else that is taking its space. Well, in a hypertonic solution, the solution outside of the cells is higher in solute. So the space in that solution is filled with solute, which means anything other than water. It could be salt, sodium chloride, or it could be glucose. We're going to use the example sodium chloride, okay? So a hypertonic solution is a solution that is higher in sodium chloride and lower in water. So I can use the same example and say higher glucose, okay, and lower water. So now we're going to track the movement of water, which is osmosis. The concept of osmosis is movement of water from a higher concentration to a lower concentration down the concentration gradient. So what we're going to look at in here, let me just get to this color, is the movement of water. So we're going to have water inside the cell and water outside of the cell. The thing about this hypertonic solution is that there's a lot of water that is inside the cell and not a lot of water that is outside of the cell because it's high in sodium chloride. So what I'm going to do is I'm going to put a lot of sodium chloride around here. Sodium chloride. So that's the solution, right? And inside the cell, there's more water than outside of the cell. Why? Because we just defined the hypertonic solution as being a solution that is high in sodium and low in water. Okay, so hypertonic solution means it's high in solute, low in water. So therefore, we can conclude that there will be more water inside the cell than outside the cell. So therefore, water moves from inside the cell to outside the cell down the concentration gradient from high water inside the cell to low water outside the cell. Why is there less water outside of the cell? Because the solution is hypertonic and has more sodium chloride. So therefore it has more solute. We can use the same example if it was glucose, which we can do that now. So let me clear this out and say that, again, this is a hypertonic solution. And I'm going to draw in yellow glucose. I'm just going to put GLU, GLU, GLU. And for blue, because it's water, I'm going to put just 2 molecules, but I'll put 3 molecules that are glucose, but 2 molecules that are water because we are looking at a hypertonic solution. So that means that there's more water inside of these cells So therefore, what do you suppose is going to happen in a hypertonic solution? Water leaves the cell and is going to move into the medium, the solution medium that it's in. Leaves the cell and goes into the solution, which is hypertonic. Okay, a hypertonic solution has more solute, less water. So therefore, we can conclude that water technically follows solute. It's going to go where there's more solute and less water. Or we can also look at it on the flip side and say water goes from high concentration to low concentration down to concentration gradient, which technically means that water follows solute. It's going to go to an area where there's more solute and less water. So what do you think happens to the cells? The cells will shrink, and the technical term for that is called crenation. Crenation. Okay, so I hope this was super clear. And now I'm going to look at the next scenario. So let me clear this out. And we're going to look at isotonic, where there's equal amounts of water inside and equal amounts of water outside. So there's net movement in and out to equalize so that nothing happens to the cell. It doesn't shrink and it doesn't expand. So the cell is healthy. And this is the type of fluid that we want as our IV fluid, okay, if you were in the hospital. Okay, now let's take a peek at hypotonic solution. Hypotonic solution means that the solution is high in water, high levels of water, okay? Lots and lots of water molecules, but low in solute. So I'm going to use this time, again, glucose as an example. So I'm going to draw glucose in inside, so we can say there's more solute here. We can even say sodium chloride, glucose, whatever, because cells have a bunch of solutes, right? But not a lot of water. So let me draw that in blue. I'm going to only put, say, 2 water molecules, but I'll put like a lot more solute, which is going to be yellow. And then we're going to put in blue lots and lots of water in the solution, not a lot of solute. Okay, so remember what I said, water follows solute, and water likes to go from an area of higher concentration to an area of lower concentration. So this solution is filled with water, so therefore water goes from a higher concentration to a lower concentration down the concentration gradient. In other words, water enters the cells, water enters all of the cells and cause the cells to expand. Cell expands and can burst, and when it bursts, it's called cell lysis. Cell lysis. Okay, so there you have it in a nutshell. Again, water goes from a higher concentration to a lower concentration down the concentration gradient. Water likes to go from an area of lots of water to an area of lower water where there's more solute. In essence, water follows solute. So if we have a solution and we dump a cell in it and the solution is high salt, then obviously it's a lot of sodium chloride and less water. So the water leaves the cell and it will enter the space, the solution, and the cell shrinks. And so that's crenation. If there's equal net water inside and outside, there's an equal net movement of water in and out, so there's no change in the shape of the cell. Hypotonic, we have the opposite. We have lots and lots and lots of water in the actual solution, but not a lot of solute. So therefore, the balance is the opposite, where the cells have more solute and less water. So therefore, water is going to go from outside of the cell from the solution into the cell because the cell has more solute and less water, while water follows solute. Water leaves the solution and enters the cell where there's more solute and less water. In essence, water follows solute. And so therefore, the cells expand, 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 and can burst, and that's called cell lysis. All right, so that was your micro lesson for today, understanding the movement of water, osmosis. All right, till next time, bye.